That's a good start. There's much more of you than I expected because it's 5 p.m. Saturday and I expected like 5 people that I already know in the front row. But thank you for all for coming here. Yeah, that's more than I expected at this hour. So my name is Mieszko Malawski. I work for CD Projekt Red. Before that, I was working for GOG.com. Working in Gwent team. Gwent is a multiplayer card game set in the Witcher world, which is a joint effort of CD Projekt Red and GOG.com. I have 7+ years of experience in PHP development, and I'm focused on good practices in general and basically everything that makes our life as developers easier and happier. I'm gonna talk today about how to keep API documentation up to date, how to maintain it, and how to test it using OpenAPI. We'll start with table of contents, so you know what to expect. We're gonna have a look at the current landscape of APIs. Then we're gonna move towards problems that we had with the documentation. I'm gonna show you what problems we had in Gwent team exactly, what is OpenAPI, how you can use it, and then finally I'm gonna show you our current workflow and how we use OpenAPI to solve the problems that we had. And I just realized that I keep hitting the spacebar when I have this thing. Amazing. Yeah, this is not supposed to happen. Sorry for that. Technical difficulties. Okay, so you know the table of contents. Let's have a look at the current situation of APIs. Raise your hand if you ever had to integrate with an external API. Okay. How many of you have to maintain or develop web API, any kind, REST, GraphQL, any kind of API? Okay, cool. There's quite a lot of you, and probably there will be more. And why? Because there will be more APIs. Why there will be more APIs? 3 things. Microservices. Microservices need to talk to each other. Clients need to talk to microservices, and they need APIs for that. Single page applications. You got your front-end framework, which is talking to back-end service via API. Finally, all kinds of public APIs, of kinds of services for sending text, emails, and so on. And all of them have one thing in common. All of them require documentation. So let's have a look at problems with documentation. Raise your hand if you ever had to integrate with external API that had missing, incomplete, or misleading documentation. Okay, keep your hand up if it was fun experience. Okay. Oh. Okay, raise your hand if you had to maintain or develop an API and you always had 100% up-to-date and complete documentation. No one? Okay, just as expected. This year, HackerRank conducted a survey among senior and junior developers, and they asked some questions, and one of them was, what is the top issue in software development? So answer for junior developers was badly written documentation, and for senior developers, it was spaghetti code, closely followed by bad documentation. But you may say, so what? Okay, documentation is an issue, but is it that such a big problem? What's the impact of bad documentation? Imagine that you have external API and your customers that you are trying to use this API want to integrate as fast as possible. They want to spend as little time on integration. They don't want to pay the developers more than they have to. And bad documentation means difficult integration. And difficult integration means slow integration. And this means that they can choose your competition. They may choose some other API because of it, just because they have better documentation. This also means more tickets to support department with questions. What do I send here? What's the request? What's the response? How do I authenticate? And you need to waste time answering all those questions, right? And yeah, more tickets to the support department. And what about internal APIs? What about microservices? Is documentation as important there? Sure it is. And again, bad documentation means harder integration, and that means that you spend more time integrating instead of delivering features, right? And it means more bugs because of people using your API differently than they're supposed to use. And finally, it's just bad experience, especially for the client team when they constantly have to work by trial and error. What we can do about this? I'm gonna show you what problems we had in Gwent team, and we'll have a look at the Gwent architecture. Gwent consists of Gwent game client, which is written in C#, and of 20 plus microservices. The client is communicating with microservices, and microservices often are communicating with each other, all using RESTful APIs. So we have quite a lot of stuff to document. How we used to work with that. You start with making change in your API. You submit your merge request, it goes through the pipeline, it goes through the code review, and it gets merged. What next? You go to the internal web page, in our case Confluence, and you update the documentation manually. Easy, right? So I remember my first week at work, and my first task was to extend the integration, extend the client to integrate with some endpoint. And so what was the first thing that I did? Well, I checked the documentation, how I can integrate with this thing. And it was not there. So I asked why. Well, if you forgot about it, you can update it. So I had to reverse engineer the code, update the documentation, then finally integrate. So the result was that our documentation was far from perfect. It was missing stuff, it was incomplete or sometimes misleading, outdated, and also it lacked business description. So quite often there are some endpoints, but you had no idea what those things do in business context, right? Why this happened? Because documentation has low priority. We don't see it as important as performance or security. Documentation is kind of like Kevin from Home Alone. I probably all seen this movie, right? Kevin Sam w domu. So nobody gives a shit about Kevin until they realize he's missing, right? Raise your hand if you love writing documentation. Yeah, just as I thought. There is no really way of testing documentation that your API works as described in the documentation. It's not part of the code review, and quite often business sees no value in it, and they don't think that the documentation can have impact on your business, but it can't, as I shown you a couple of slides before that. So we knew we had to do something about this. We need some better process of making and maintaining documentation. We decided to give a shot to OpenAPI. What is OpenAPI? OpenAPI is a specification. It's a standardized way of describing RESTful APIs. So it's a standardized way of saying what are the endpoints, what are the request and response bodies, headers, how to authenticate, and so on. It's readable both by humans and machines, and it's language agnostic, doesn't care about your implementation. As far as it's concerned, you can write in COBOL. Lastly, it allows you to write API documents. What is API document? API document is just a YAML or JSON file which contains API definition. API definition is something that actually describes your API. So all your endpoints, all your requests and response bodies, how you authenticate, and it conforms to the API, OpenAPI specification. And from that definition, from that document, you can generate documentation, you can generate mocks, you can generate client implementation, SDKs, and finally servers. Before I'm gonna show you some examples how to use it, a word of clarification. So sometimes people say Swagger, sometimes they say OpenAPI. So historically, Swagger was the name of the specification, and now the current version, the version 3, is called OpenAPI, and Swagger refers to the tools built around the OpenAPI specification. So all the generators, validators, and so on. So how we can use this thing? There are two approaches to that. Code first, as name suggests. You write your, you make the changes in the API, you write the implementation first. You extract the definition from the code. So there are tools that allow this. They can analyze your controllers, they can read some annotations, and from that they extract the definition of your API. And from that you can generate the documentation. So this approach requires the least work from you. You just write the code, you write some annotations, and that's it. The rest of the magic just happens with few simple commands. Personally, I prefer the other approach, the definition first approach, where you design things properly first. You design your API and you write the definition based on the design, and you generate mocks from that optionally if you need to, and then you write or generate or partly generate the code from the definition. You generate documentation from the definition, and finally you test that your implementation works exactly as described in the definition. Okay, enough of talking. Let's show you some examples. So here's an example project structure. This is very simplified example with API that serves cards collections. Well, the Gwent is a card game, so it requires cards to operate. And you have docs directory where the API YAML file sits with the description of the API, how this file looks like, what's the definition. I'm not gonna go through all the features, all the things you can describe in the API definition, because there's just no time for it, and frankly you can just go visit the web page and read the specification. I'm just gonna show you some key features so you have some understanding how it works. So you start with providing some basic information about your API, what it is, what are the base URLs, what are the environments, and who can be contacted in case it's not working properly. And then you have the most important part, which is the list of possible operations. What is operation? Operation is just combination of HTTP method and URL. In this case, we have one operation, which is get on /cards URL. And for each operation, you can have a list of possible responses and with HTTP codes. In this case, there is just one possible response, which is HTTP 200, and the response body is JSON body containing array of card items. Here you can also describe your security, authentication. If this was post or put, there will be probably some request body or some request parameters and so on. And finally, you can describe what a card is. It's just a JSON object containing three fields, ID and name, which are strings, and power, which is an integer. And so the response will be just array of card objects. Okay, so we have this OpenAPI definition file containing the definition of our API. How do we generate documentation from that? Very easy. I'm using a tool called Swagger UI, and they expose a Docker image. So with this one command, I just pass the definition, the file containing the definition to the Docker image, and it serves the documentation on example docs.gog.docker on port 8080. Let's have a look how it looks like. That's our generated documentation with this single line, with this single command. We get the documentation. We can see what are the possible operations, what is the base URL, and we can investigate each operation. We can see what are the required parameters, what are the possible responses, and so on. Okay, so we have the documentation generated, but what about testing? What about checking that our implementation works exactly as described in the definition? So we have a couple of tools for that. The most popular of them is Dread, and there are two things you need to know about the Dread. First thing is that the 2012 movie is much better than the old one with Stallone, and the other thing is that it's a JavaScript library, and this library it reads your definition and goes through all the possible operations. And for each operation, it generates the requests based on some examples provided in the definition, sends the request, and then validates the response. So in our case, it will look that there is only one get cards operation, and it will send the get request, and it will then expect that the response is 200 with array of card objects. But we don't use it. There's a reason for it. Actually, two reasons for it. One is that it's not fully supporting the current version of the OpenAPI. There is some support, but it's still in VIP. The other reason is that it's not as easy to integrate with existing PHP test suite. It offers some language-specific hooks that you can use to provide some test data and so on, but it's not as straightforward as just just plugging in the thing into your existing workflow. So we thought that we need alternative solution, and I came up with something called PHP OpenAPI Validator. The name is not as fancy as Dread, but I believe it's very descriptive, and it works a bit differently. This time you make the request. You have to use your client, test client, or any client to make the request. You pass the request to the validator, and you pass the response to the validator, and what it does, it tries to figure out what operation you are executing. So in this case, I'm making get on /cards, and the OpenAPI validator will figure out that, okay, this is get cards operation, and what I expect from get cards operation, I expect array of card items. If it will not receive array of card items for some reason or some different HTTP code, it will return some errors. So let's have a look how it works exactly. Again, we expect array of JSON objects. Sorry. This is our example controller. This is not how we serve JSONs in production. This is just for test purpose. And this is our test case. There's quite a lot happening here right now, so I'm just gonna go through all of it. In the top, we load the validator. We pass the specification to it. Then we have our actual test case where we make the request. We can have some extra assertions afterwards, but the most important part is we have the base make request method. We make the request there using the Symfony test client. We pass the request URL and method to the validator, and we pass the response status code and the body, the coded body to the validator. So validator, we see, okay, this is get on /cards, so the only possible response is 200 containing array of card objects. And if it will not receive that, it will return some errors. How this works. By the way, there will be no live coding on this presentation because I've seen so many presentations go wrong because of it. So only static images, sorry, you have to trust me. Yeah, this is the result. We ran the tests. It's a assert that true is true, right? But this is boring. Let's break something. Let's introduce some errors. Here I'm removing the ID field from the second object. Let's see what will be the result. When we get an error, we get the property ID is required and it's missing from the second object. Of course, we iterate from 0, so 1 means second. Another example, something a bit more subtle. What is wrong here? Exactly, and this is quite common issue. We actually had a lot of problems like this, and if your client happens to be written in strictly typed language, this can be an issue. String value not found, but an integer is required. So not only we test the structure, we also check that the types are of correct, that the fields are of correct type. So how all of this fits into our current development flow? We start with designing API changes, so we prefer the design first approach. We update the definition, the API YAML file inside the repository, and then we submit merge request. It goes through the pipeline, and in the pipeline we run JavaScript library called Specky. Specky is just linter for OpenAPI definitions. It just checks that your definition is, the syntax of the definition is correct. And then it goes through code review, so other people have a chance to see what changes in the API you're trying to introduce. And finally, it gets merged. When we have the definition merged, we start working on the implementation. You write the implementation or partly generate. Then it again goes through merge request, goes through pipeline. This time we run the tests, and we run the tests with the OpenAPI validator, so we perform contract testing as a side effect of running our test suite. Goes through code review, it gets merged. But there is some part missing here. What is missing here? We could use that, we could do that, but it's not required. There's something else. There's something else missing. Where's the documentation here? We tested the thing, we have the definition, but what about generating documentation? We have another tool, documentation aggregator. This aggregator is just one web page with the documentation for all our APIs. And what it does, it's every hour, it checks every repository, goes into the docs directory, reads the OpenAPI specification, and re-renders the documentation. So anytime you merge, you introduce some changes in the specification, it gets updated, worst case scenario, with 1 hour delay. So it fetches the definition, and then we get the documentation updated. So result of all of this is that our documentation is updated and available automatically, and it is always up to date because of the constant re-rendering of the documentation. The implementation is tested, so we know that our documentation is not telling lies. The definition is the part of the code review. That's important because there's just this extra chance that people can have a look what changes you're trying to introduce before you write any code, and this saves us a lot of time. It's under version control, so you can see how your API evolved over time. And finally, no time spent on maintenance. So we have saved tons of time of manual work on manually maintaining documentation. The only thing that we do, we write the definitions in the YAML file, which is easy, and everything else happens automatically. So we can focus on things that really matter, things like performance, security, proper design, and not just manually updating HTML or JSONs. Bonus point for coming here so late on Saturday. I didn't tell much about code generation, and this is probably the most important part. As of now, we are not using code generation of any sorts, but this is something that we are looking to do in the future. A lot of our code is just simple boilerplate code which transforms objects into JSONs back and forth, or some simple controllers, some simple validators. Most of this stuff could be easily automated and generated from the definition. There are some challenges regarding OpenAPI. You get to learn it. You have to learn it. There are some tools that can help you write those definitions, that can offer you some help, but still you should get familiar with the specification and spend some time on it. It's only for HTTP, and specifically it's only for RESTful APIs. If you are using GraphQL, I believe there are some similar tools that allow similar features. And if you are using gRPC, well, gRPC has the definitions built in the technology, so you don't need extra tool for that. There is no clear way of describing versioning of APIs. The most common strategy is just to have separate file for each API version, which is not exactly very optimal. So how to get started with this OpenAPI thing? Read the OpenAPI specification. Go to the page, get familiar with some examples. Then write your first definition. And there is quite a lot of tools that can help you do that. There is the PHP Storm plugin, which offers auto-completion and validation. There is this Specky library, which I mentioned before, which I believe currently it was renamed to Spectral, which offers some validation and linting. Generate the documentation using Swagger UI or any kind of other tools. There's just tons of them. Finally, test it, that your implementation works as described. And finally, there's this awesome OpenAPI.tools page, which offers like tons of tools that can allow you to do amazing things. Before we finish, there are some key things I want you to remember from this presentation. Documentation, sorry. That's a sorry for the spoilers, right? Han Solo dies. Documentation is important. It can affect your business. The key to success is the automation. As everything that can be automated, it should be automated. Documentation can be tested, and finally there is just tons of tools that can you help doing that. You don't need to do everything by yourselves. Thank you. Any questions?